we're going to do nodal analysis when there is a voltage source between two nodes. And there's only two cases. Either it's one voltage source to ground, and this we did last class. And now the more interesting one is voltage source between two non-reference nodes, non-ground nodes. In this case, we say there's a supernode. So this fancy thing we're learning today is really supernodes. That should have been the title of the class, really. And I'll give you an example and say what happens. So this is better exemplified with a circuit. So I'm going to start by drawing this. 2 milliamp current supply, 20 kilo ohm, and here comes the voltage source that we're concerned with. And there's 5 milliamps going up. You know, this is 20k, and this is 30k. And this is 10 volts. And in this case, let's see, how about I actually connect branches here. In this case, I'm going to use almost exactly the same method as before. I'm going to first say where I want my currents to be going. And I think here the question is find the nodal voltages. Now the nodal voltages means I'm going to first decide on the currents here, on the current directions. These I-20 and I-30 going down. Then I'm going to mark the ground. And all that's left is for me to mark the nodes. And I'm going to again draw here. Oops, I only have one colored pencil. The other one is normal pencil. You see, really this circuit has 1, 2, 3 nodes. One of them is ground. So I'm going to call this guy V1 and V2. However, V1 and V2 form a supernode because they are connected only by a voltage supply. It could be an independent or a dependent voltage supply. And that means I can now, next time I'm going to have a better pencil situation here. I can now sort of see these two as one. So if I look at V1 and V2, I can already write V1 minus V2 equals 10 volts. So this is one of my equations. And now I can still do the KCL for the V1, V2 supernode. So I'm going to look at currents. Great, thank you. Currents that come in and out of those supernodes. So look, this is my I-20, this is my I-30. I'm going to do KCL 2 milliamp. First I'm going to look at everybody's coming in. And now where I painted green here, maybe I'm going to paint blue now that all of a sudden have new colors. Everything painted here around the two nodes make one supernode. Alright, all currents coming in equals all currents coming out, so 5 milli is in equals everybody coming out. 2 milli plus I-20 plus I-30. So this is it. These are my two equations. I have these two variables. I want to get rid of I-20 and I-30 by using Ohm's law. I-20 equals V1 over 20K and I-30 equals V2 over 30K Therefore, that same equation is 5 milli equals 2 milli plus V1 over 20k plus V2 over 30k. I'm going to multiply this by 60. Actually, first I'm going to say 3 milli equals V1 and I'm multiplying this by 60k, which is 180 equals 3 V1 plus 2 V2, because 3 milli times 60k is 180. And then I know that V1 minus V2 equals 10, so I know that V1 equals 10 plus V2, so 180 equals 3, 10 plus V2 plus 2 V2, 180 equals 30 plus 3 V2 plus 2 V2. Therefore 150 equals 5 V2. Therefore V2 equals 30. I hope you can see here, 30 volts. And therefore V1 equals 40 volts. So this is how you do a really straightforward supernode circuit. And next time I'll do a harder one.